Okay, the next problem is problem 8. I just showed you the work. This one's really easy. Write two equations, one for perimeter right here, and then obviously the length is 4 times the width, and then substitute. And you'll get W equals 8. Plug W back in, you get L. So that one's easy enough. You could probably figure that one out just by looking at the work. Next one, the only way I would know how to do this one is substitution, so I would solve one of these for x or y. So I'll solve it for x. You get 4x equals 3y plus 7. Divide both sides by 4. And what makes this one tough is I'm dealing with fractions obviously the whole time. So this might be tricky, but we're going to have to plug this equation in for x right here and right here. All right, and that leaves us with this equation then after you've substituted. And then let's see, 4 goes into this 4 times. I need to distribute the 4, and I also need to FOIL this out. So this becomes 9y plus, actually that's squared. And this would end up being 42y plus 49 all over 16 minus 12y plus 28. And actually this negative sign needs to be distributed as well. So this would be a minus. And then I'm going to multiply through everything by 16 because that way it gets rid of this 16. But I need to multiply everything through by it, which gives me this next equation, 9y squared plus 42y plus 49 minus 192y minus 448 plus 16y squared equals negative 624. Now I can add like terms. Gives me 25y squared. I can add the y's together here. Should give me negative 150y. And I can add the numbers together, but I have this number as well that I'm going to have to move over and subtract or add. And that gives me 225. So we've got a regular quadratic here. It looks like I can factor this, or factor out a 25. In which case I have y squared minus 6y plus 9, which is a perfect square trinomial, y minus 3 squared, not cubed, squared. And that's my answer then, y equals 3. Now if you plug this back into one of these equations, any one of these, like there for example, you should get y equals 4, or x equals 4. Okay, the next problem wants us to know the equilibrium points between these two functions, the cost and the revenue. I would set them equal and try to use algebra. Obviously we can use our graphing calculator as well. But this looks like it might be doable with algebra here. If we add 2x to both sides, for example, we get 4x squared over here. Subtract the 500x, it should give us negative 400x. And we still have the 3600. We want to know where that's equal to 0. So let's try pulling out a 4. And we should get this. So then it looks like we need to try to factor x minus 90 and x minus 10. So our two answers then are 90 and 10. So it wants the smaller one first, so that'd be 10. And then the bigger one. Now you might have been able to read this from the graph. I don't know, it was a little hard for me to see the units on here, so, but this is supposed to be 10 apparently, this first one, and this is supposed to be 90. Okay, next problem, there's probably multiple ways to solve this as well, but I'd use substitution, so I'd take the first equation and rearrange it to make it x equals 4y, and then I'd substitute it in right here. So you have 6 times the 4y minus y squared equals 0. This gives us a quadratic. If I put it in standard form, we have negative y squared plus 24y equals 0. You can multiply through by a negative 1 if you want. That makes this positive and this negative. And you can factor out a y. So you have y minus 24. And therefore, our two answers are y equals 0 and y equals 24. There's obviously going to be x coordinates that go along with that if we substitute back in then. So if you plug in y equals 0, you get x equals 0. And if you plug in y equals 24 right here, for example, subtract 24 from both sides and divide, you should get 6 for x. So it looks like it wants the smaller one first, which case that'd be 0, 0. And then it wants the bigger one, so that'd be 6, 24. And this one wasn't right because I plugged 24 in for x and not y. So it goes in for y right here, which gives you negative 96. When you add it to both sides, you get x equals 96. So this should have been 96, not 6. Okay, the next one says it wants me to use elimination. Obviously, I could use my calculator. These are actually two ellipses that have an intersection of 4 points then. You can multiply the first equation by like 4, and that gives us 12x squared minus 4y squared equals 44. And the second equation is the same. And now we can add to eliminate. This gives us 13x squared. These cancel out. This gives us 52. So x squared equals 4. If I square root both sides, I get x equals plus or minus 2. So looks like a would be 2 then. There's my plus and minus 2, plus and minus 2. And then I can plug that in. If I plug in, 2 in any one of these equations, I'll plug it into the bottom one here. You get x squared plus 2 squared is 4, so it'll be 16 equals 8. Subtract x squared equals, whoops, I plugged it in the wrong one again. So x is 2, so it goes in for x. So that'd be 4 plus 4y squared equals 8. Subtract from 4, you get 4y squared equals 4. Divide, you get y squared equals 1. Obviously, you get plus or minus 1 then for b, which is what we want for b. Here's the minus 1, here's the plus 1. All right, then the last problem, a circular piece of metal has a diameter of, well, I'm going to draw the diameter in like this because it goes through the center right there. Splits this rectangle into 2 equal parts. And then it says the edges are to be cut off to form a rectangle of area. So I'm going to call this L, I'll call this W. The area then, L times W, is 20. And they want to know the dimensions. Well, I can write in a second equation because I have the Pythagorean theorem for this right triangle. So I could do L squared plus W squared equals 20 squared. And now I can just substitute, divide both sides by W, for example, and substitute in. This would be 20 over W squared plus W squared equals 400. And this is just a lot of algebra from this point. We have 400 over W squared plus W squared equals 400. I'd multiply through by W squared. And this gives me 400 plus W to the 4th equals 400 W squared. Then I'd write this in standard form. So I'll move these over to the right. You have, I'm sorry, this is W to the 4th right here. So I'd have W to the 4th. Move this over to the left then. Minus 400 W squared plus 400 equals 0. And now you can look at this as a quadratic. Let me call x, I'll throw in another variable here. I'll call x equal to W squared, in which case this is really x squared minus 400x plus 400 equals 0. If that helps you, because then you can see you can just use the quadratic formula, get 2 answers for x, and then take the square root of both of them. So I'm going to do that in the quadratic program. All right, I got these 2 answers. This one right here, which I had to do on the calculator, it came out to 398.99, that rounded. And I got this one here. So I took the square root of both of them, and this one gives me 19.97 about, and the square root of this one gives me about 1.001. So there's my 2 answers. I would call this the length and this the width, obviously. What we solved this equation for actually was x, but then we took the square root, so we found w. So actually what these answers are for the width. But it turns out that, so if we took the smaller one, for example, and we plugged it back in to this equation, we would get this answer right here for the length. So there's your length and there's your width.